Welcome to part 2, Factorising Cubes. So in part 1 we looked at expanding a product that looked like this. Now we're going to look at something very different. We're going to look at these fellows, which is but you can see they're very different expressions, just as in the same way if I'd written a plus b all squared, that's very, very different from a squared plus b squared. So a plus b cubed is nothing like a cubed plus b cubed. Now it turns out that this sum of cubes can actually be factorised. We can pull an a plus b out, we get an a squared. There obviously has to be a b squared somewhere. This turns out to be what makes it work. Also a version for the difference of cubes. Pull out a subtract b. Signs are a little bit different, and if you're surprised by that plus sign there, note that the minus b times the plus b squared will give us the minus b squared. Let's just highlight the difference between them. If we have a plus here, we have a plus here, we have a minus here, a minus here. That sign changes, that sign changes. This is always plus. Okay, let's just do some of these. So how about we do 8t cubed minus p cubed. Yeah, it's a difference of cubes. We recognise that's 2t all cubed. Subtract p cubed. Pull out the minuses, and then it's going to be that squared plus that squared, and the other term is going to be a plus. Multiply the two terms, and there we have it. Let's do one more. 216 x cubed . Not too much harder. You can see we've got two cubes there. That's 6x all cubed plus 5y squared all cubed. When we fix that up, we're going to get 6x. We're going to square that term. Squared. Subtract the product, 30x y squared, careful there, plus 25y to the fourth. So as before, I think an important thing is when you see a number like this, move it to this inside brackets. Same here. Put it inside brackets as a cube, and then you won't make mistakes. Okay, 3 ideas for working with factorising these cubes. First idea, it's very useful to recognise the cubes. So let's just go for our first 10 digits. If you know these cubes, you'll save yourself some effort. 27, 64, 125. These you might not know. 216, 343, 512, 729, and 1000. I'd really recommend you learn the first 10 cubes. Okay, here's a second thought. For many years we've been factorising difference of squares. And now we know we can factorise difference of cubes. We also know now we can factor the sum of cubes. What about, though, the sum of squares? Can we do anything with them in terms of factorisation? Answer is no. And why is that? It's because of these fellows. When we multiply them out, the a squared plus the b squared always has this 2ab. We can't get away from it. Okay, it's all very well for me to say this. But how do we know? Where did it actually come from? Well, the answer comes from thinking about what would happen if we divided a plus b cubed by a plus b. Or another way of asking it is, if we think we can pull an a plus b out, what do we multiply to get a cubed plus b cubed by? And there's a handy little technique we can do to see that. Let's imagine we have a product a plus b, and we want to multiply it by something, some long expression, so that our final result is a cubed plus b cubed. Okay, it's likely to start with an a squared. So if we had an a squared, multiplied that by the a, we'd get an a cubed. But we've got a b, so we're also going to get a squared b. Don't want that guy, so we need to take him off. Okay, these will cancel out. Now the only way I can get a minus a squared b when I multiply by the a is to multiply by a negative ab. Now let's multiply that out here, so we get a negative ab squared. Don't want that negative ab squared, so let's put in a plus ab squared. What times a is going to give us ab squared? A b squared. B squared times b squared is b cubed. So what we've done is we've cancelled out the middle terms, and we've got a plus b cubed, which is what we want. What I've actually just shown you here is an interesting method of doing polynomial division. Using what's called the Galley method, or strictly speaking, the reverse Galley method. Something I learnt from the amazing Dr. James Tanton, who does many videos on YouTube. And you'll be looking at polynomial division later, at the end of the year.